Welcome to Deep Dive Learning by HaleForm.
This is episode 7, S3D Support Modeling Tips.
Today, we're really digging into something pretty crucial for plant design in Intergraph Smart 3D, or S3D, yeah.
That's right, we're looking at the placement of hangers and supports, the real nitty-gritty stuff.
And our goal here, our mission for this deep dive, is to pull out the key takeaways for you. We're drawing on insights from HaleForm Technology Solutions and also a really useful quick tip guide that tackles common issues people face.
Exactly. For you, the learner, maybe wanting to get up to speed quickly without getting bogged down, we're distilling the essential info, trying to help you understand and, overcome those challenges in S3D support modeling.
We want to provide that clarity, those aha moments. Okay, so let's start at the beginning. Why? Why is getting these hangers and supports placed just right so important?
Yeah.
Seems kind of straightforward sometimes.
Well, it might seem that way, but accurate placement, it's absolutely critical. Think about it. It's all about the structural integrity of the whole piping system. Right. These supports, they carry the weight, the pipe, the fluid, insulation, everything. They prevent too much stress on the pipe itself and also on the equipment it connects to.
So it's not just about stopping things from falling down. It's about managing stress, preventing failures.
Precisely. And you have to consider things like thermal expansion, vibration. It gets complex. Proper support handles all that.
Okay, makes sense. Now, that quick tip document we mentioned, it points out some common head scratchers. Let's tackle the first one, the support that just fails to place, poof, nothing happens. Or maybe the wrong one shows up entirely. What's going on there?
Yes, the disappearing support act. It's frustrating, but often it comes down to the intelligence behind S3D, the rules, and the catalog data.
Rules?
Yeah, the rule configuration in the piping specification. These rules basically tell S3D which support to use based on criteria like, pipe size, maybe the operating temperature, the load it needs to carry. So if those rules are set up wrong or they're missing for the specific situation you're in, maybe they even point to a support part that doesn't actually exist in the catalog.
Then the software just throws its hands up.
Kinda, yeah. It can't follow the instructions, so either nothing appears or it might grab the next best thing, which could be totally wrong.
And it's not just the rules themselves, is it? What about the actual parts?
Good point. Catalog issues are another big one. The required support component, or maybe even just one tiny part of that component assembly, might be missing or just defined incorrectly in the S3D catalog.
So the definition doesn't match reality, or it's just absent.
Exactly. And then there's the third piece, mismatched properties.
Properties of what? The pipe.
The pipe run, yeah. Things like its nominal piping diameter NPD or its temperature, insulation thickness. If those details on the actual pipe run don't match the conditions set in the support rule.
The rule doesn't fire.
Right, it doesn't trigger. Same goes for the supporting structure. Maybe its material type or its elevation doesn't meet the rules criteria. It's like a three-way check.
Yeah.
Rules, catalog, and the actual object properties.
Wow, okay. Lots of places for things to go off the rails. And I guess there's always a simple explanation, too.
You mean clicking the wrong thing?
Yeah. Did I just select the wrong pipe run or the wrong beam?
Absolutely. Incorrect selection is always a possibility. Simple, but easy to do in a complex model.
Okay, so if you're staring at the screen, wondering where your support went, what's the playbook? What steps do you take?
First things first, you gotta play detective with those piping spec rules. Dive into the relevant piping materials class, the PMC.
PMC.
Yeah, that defines all the standard bits for that piping system. You need to really scrutinize the support placement rules in there. Do they cover your situation? Are they actually pointing to real parts in the catalog?
Rule validation, step 1.
Step 1. Then step 2 is check the catalog itself. Confirm the support assembly, all its little pieces actually exist and are defined properly.
Make sure the ingredients are actually on the shelf.
You got it. Then, step 3, inspect the object properties. Use the properties command in S3D, check the pipe run details, check the structural member details. Do they line up with what the rules expect?
Okay, properties check.
And finally, double check your selections. Did you really click the pipe and structure you intended to?
Seems logical, but I bet in a rush it's easy to miss one of those.
It really is. And sometimes the issue is deeper. Maybe the rule setup is genuinely complex, or there's a subtle catalog error.
That sounds like where you might need some outside help.
Potentially, yes. And this is an area where, for instance, HaleForm Technology Solutions really shines. They have deep expertise in S3D administration, catalog building, specification customization. If you're hitting persistent roadblocks, they can dig in and figure out those complex rule or catalog problems.
Good to know there are specialists for that.
Okay.
Okay, so that's issue 1, the no-show support. What about when it does show up, but it's, well, it's rotated funny or offset or attached to the wrong bit of steel?
The wonky support problem, another classic. And this one often comes down to precision during placement.
How precise you are with the mouse click.
Pretty much. A big cause is using ambiguous placement points. If you just click vaguely on a big steel surface instead of snapping to a specific point or an edge or maybe the center line.
The software has to guess the orientation.
Exactly. It makes an assumption, and it might not be the one you wanted.
So being sloppy with the click
leads to sloppy placement. Also, not using the precision tools effectively. S3D has powerful tools like pinpoint, letting you type in exact coordinates or offsets.
I've seen that one.
And angle locks to constrain rotation, or plane locks to fix it to a specific plane. If you're not using those when needed, things can go adrift.
Just kind of eyeballing it. It doesn't really work in 3D CAD, does it?
Not for precise placement, no. Another factor can be the structural geometry itself.
The beam or column you're attaching to.
Right. If its surface is really complex or not perfectly flat or just poorly defined, sometimes you see this with polymesh geometry that's maybe imported from another system.
Okay.
The software might struggle to figure out the correct orientation relative to that messy surface.
So a messy model leads to messy supports.
It can, yeah. And finally, just being confused about the coordinate system you're working in, global versus local, and how the support itself is defined to orient. That can trip people up.
Okay, so how do you wrangle these wayward supports back into line?
Precision. Really lean on those tools. Use pinpoint when you need exact locations or offsets. Don't be afraid to use angle locks. Maybe lock it to 90 degrees or plane locks to keep it on the right elevation or plane.
Be deliberate.
Very deliberate. Define clear placement points. Don't just click near where you want it. Actively select a specific point or an edge or a nice flat planar surface if you can.
And if the structure itself looks suspicious,
take a closer look. If the geometry near your support point is overly complex, see if it can be simplified slightly. And maybe avoid placing directly onto weird polymesh surfaces if they seem to be causing trouble.
check the geometry. Got it.
And always be aware of your active coordinate system, global or local. Understand how it affects placement. And hey, don't forget the basics. If it places wrong, you can often fix it afterwards with the move and rotate commands.
The trusty move and rotate.
Just make sure you select the entire support correctly when you do that using the piping features, or maybe the assembly filter often helps grab everything.
Okay, good tip. So we've got supports not showing up, supports showing up wonky. What about when S3D just throws up its hands with an error message during placement? Things like constraint overdefined or failed to evaluate.
Yeah, the dreaded error messages. These often signal that the software hit a logical dead end. It couldn't resolve the placement based on the rules and the geometry.
What causes that kind of conflict?
Several things. One is genuinely conflicting rules. You might have 2 or more rules in the spec that could apply to the situation, but they tell the software to do different, incompatible things.
Too many cooks.
Sort of, yeah.
Yeah.
The software gets confused. Another possibility is what's called over-constrained geometry. Meaning the way the pipe and the structure are positioned relative to each other is just too tight or complex for the standard rule logic to find any valid placement that doesn't violate some constraint.
So the model itself is the problem again.
It can be. Or inaccurate modeling of other nearby stuff. Maybe a piece of equipment or another pipe is slightly misplaced in the model. And the rule tries to place the support based on its logic, but it ends up clashing with that incorrectly modeled object, causing an error.
Okay.
And sometimes in really unique, complex geometric setups, the standard rule engine might just struggle. It has its limits.
So when those errors pop up, what's the troubleshooting sequence?
Again, start with the rules, review them carefully. Look for those potential conflicts or ambiguities. Can they be simplified?
Check the rules first.
Then, check the neighborhood. Look closely at the surrounding geometry, the pipe, the structure, anything nearby. is it modeled accurately?
Verify the local model accuracy.
Right. And after you do manage to place supports, especially if you had errors, definitely run interference checks. Make sure you didn't accidentally create a clash.
Run clash checks. Standard practice, really.
Should be. Now, sometimes, in very rare cases with truly bizarre geometry where rules consistently fail, you might consider a manual override.
Uh-oh, sounds dangerous.
It needs extreme caution. It should be a last resort, really. If you do it, you absolutely need clear documentation explaining why, and ideally get it reviewed by an experienced user or admin. Bypassing the rules can cause problems down the line if you're not careful.
So document if you override.
Absolutely. And don't forget to check the error logs S3D generates. Sometimes they contain more specific clues about why the placement failed.
Good point. Dig into the logs. Okay, one more common issue area. Performance. What about when placing or modifying supports, especially lots of them or complex ones, just seems to slow the whole system down? It gets sluggish.
Yeah, performance degradation. This often relates to the level of detail, the geometric complexity within the support component models themselves in the catalog.
Too fancy.
Kinda, yeah. If supports are modeled with tons of tiny details, every single bolt head perfectly rounded, every weld shown graphically, that adds up. It increases the load on the software when displaying and manipulating them.
Even if you'll never zoom in that close.
Exactly. The other factor is just the sheer density. Having a lot of supports in one area creates a huge number of relationships that the software needs to constantly track and manage.
So how do you keep things snappy?
Well, optimize those support models in the catalog. Simplify the geometry where you can. Remove excessive detail that isn't needed for, say, generating drawings or material takeoffs. Find the right balance.
Streamline the catalog parts.
Right. Also, manage your workspace. In really congested areas of the model, try working with smaller, more focused views or workspaces rather than having the entire unit loaded.
Work smaller.
And consider placing supports in logical batches rather than trying to do hundreds all at once in a super dense area. Break it down.
Batch placement. Sensible.
And finally, the obvious one. Make sure your workstation actually meets or exceeds the recommended hardware specifications for S3D. You need enough processing power and memory.
Right. Don't try to run it on a potato.
Yeah.
Okay, so we've covered a lot of troubleshooting. What about preventing these headaches in the first place? Any key best practices?
Oh, absolutely. Prevention is always better. A huge one is upfront validation.
Before you even start modeling heavily.
Exactly. Thoroughly test and validate your support rules and the associated catalog parts before the main modeling effort gets underway. Catch problems early.
Makes sense.
Yeah.
What else?
Consistent training. Make sure designers really understand how to use the S3D support placement tools correctly, including pinpoint, the locks, the snaps, and that they know the project's specific standards.
Train the team properly.
Emphasize precision, always. Encourage using those snaps and locks routinely, not just occasionally.
Precision is key.
And implement regular checks. Build model reviews and interference detection runs into your regular workflow, not just as an afterthought.
Proactive checks. Good list. And I imagine establishing these kinds of robust workflows is something else specialists can help with.
Definitely. Again, HaleForm Technology Solutions has a lot of experience not just fixing problems, but helping set up projects for success with efficient workflows, best practices, and customized solutions for hangars and supports.
So if people are running into these issues repeatedly or need help setting up complex rules or custom supports,
HaleForm is a great resource. Their team includes experienced SBID and Smart 3D administrators, modelers, programmers. They cover the whole spectrum. They also handle things like Smart P&ID projects, P&ID to SBID conversions using automation, and that deep catalog and piping spec customization we talked about.
and how can folks reach out if they need that kind of expertise?
They can contact HaleForm at business.development@haleform.com.
Okay, business.development@haleform.com. Got it. So let's wrap this up. We've gone through quite a few common challenges and solutions. What's the big takeaway for our listeners?
I think the main thing is, by understanding why these common issues happen, the rules, the catalog, the geometry, the placement techniques, and by knowing these troubleshooting steps and preventative measures, you can really improve your efficiency and accuracy when you're placing supports in Smart 3D. It's about working smarter.
Absolutely. It sounds like paying real attention to those details, the rule configurations, making sure the catalog is solid, using precise placement, being proactive with checks. It genuinely saves time and prevents those potentially costly mistakes later on.
It really does. And remember, if you hit those really tough snags or need something highly customized, expert help like that from HaleForm Technology Solutions is available.
Right. So here's a final thought to leave you with. Think about your own projects. How much effort currently goes into validating support rules and catalogs before major modeling starts? Considering everything we've discussed, what's one practical step you could take on your next project to implement a more rigorous upfront validation process for hangars and supports, potentially saving yourself headaches down the road?